visual ways of building machine learning models. Even a beginner can easily get started with Google AI Studio. And also I'll be finally talking about Gemini as well and some of the RAG approaches for those who have already worked with some sort of a large language models. So without further ado, let's get started. So before I move on to my presentation, I want to show you all a quick video.
Finaki, Bard, Musical M, Bard, AI, Musical M, Finaki, Bard, AI, Finaki,
AI, generative AI, machine learning, AI, semantic understanding, generative AI, Palm 2, Gecko, Otter, Bison, Unicorn. Gecko is Palm 2, SecPalm, Palm 2, AI, MetPalm 2, language model, MetPalm 2, AI, Palm 2, AI, DeepMind, AI, AlphaGo, Transformers, sequence-to-sequence models, DeepMind, Gemini, Palm 2, AI, Bard, Palm 2.
Large language models, Bard, large language model, Palm 2,
Right.
Bard.
So I think if you have already heard about this buzzword called large language models and generative AI, which is a very trending topic these days. So I would say this is the future of the machine learning, and it's going to be adaptable to any industry as we are working with it. So like the presentation title says, we are going to talk about Gemini and how you can use it for multiple use cases. And also we'll be talking about some beginner-friendly topics such as prompt engineering as well as prompt generation. So yeah, so let's get started. So in a nutshell, we can call the GenAI as a type of AI that generates content for you. So this could be text, this could be images, this could be videos, this could be audio, right? So I'll give very basic examples for this. So those who have already seen this to ChatGPT, so I believe all of you have used ChatGPT, right? So nowadays there's no one without knowing ChatGPT as well. So, it generates text for you, and sometimes it generates codes for you as well. You can ask the things that needs to be generated from ChatGPT. And if you have a look at Midjourney, right? So I believe some of you all might have heard about Midjourney as well. It's a Discord bot. It comes as a Discord bot. What you can do is you can ask Midjourney to generate images for you, right? You can give the type of images that you wanted, and it generates the image. And also we have some other image models as well, which generates image for you. So there are a lot of things in that space as well. And that brings us to audio side, right? So this is not all about images and text. So for an example, if you have heard about this tool called Suno AI, SUNO.ai, which is capable of generating audios. So for an example, I'll give a very funny example. So I believe all of you have heard about the Sinhala songs, the AI generated Sinhala songs, which came up recently, which is very funny. Those are also generated with that tool called Suno AI. So if you have heard about those songs, definitely, I know you can understand the capabilities of these models. So it's that powerful. So in that case, with that being said, I want to move forward to the other aspects as well of the proceedings. Right. So anyway, what is LLM? So this is for the beginners, right? So basically, a large language model is basically all about generating the next tokens. So for an example, in this case, you can see we have sentence of it's raining cats, and you can see there's a bag of words. So this is a sentence, this is the start of the sentence, and you can see these are the predictions, right? To complete this sentence, what are the most suitable words that should replace the latter part of the sentence? So for an example, if you have a look at this these four words, you can see it says it's raining cats, and you can see these are the bag of words. So in this bag of words, you can see there are different types of possibilities. For the first word of dogs, which has a possibility of 90%, and the second one has a possibility of 0.03%, and then we have drops, fish, wind. Likewise, you can see there are multiple possibilities. So you guys might be wondering how these possibilities are being generated. So these large language models are being trained with billions of parameters. For an example, if you have a look at ChatGPT and Gemini, these are also trained with a lot of textual data, text data, right? Gathered from multiple millions of sources online. So in that case, these models have been fed with multiple text combinations and text data. So the models would understand, by having a look at multiple sources, they would understand what is the next combination that should be the ideal wording, right? So in this case, you can see cats and the next combination has been given for dogs. So in that case, dog is going to be the most suitable completion sentence for this particular sentence, because that has been based on multiple training materials. It has been given this score of 90%. So moving forward, if you take another example, roses are red, right? So if you have heard about this sentence, what comes to our mind, right? So obviously, when you hear roses are red, we obviously know the next sentence is going to be violets are blue, sugar is sweet, right? So in human mind also, that's how we think. So when you were given a sentence, we know what needs to be completed if we already have access to that information, if you already have access to that knowledge base. So in this case, if you have already heard about roses are red, we obviously know violets are blue is the next part of the sentence. So in the same way, these large language models are also being trained in that way, based on multiple knowledge sources. So in that case, the large language model also would understand what is the next combination looks like, right? So in the similar way that the human mind understands what is the next combination. And talking something interesting about large language models. So there are some layers. So in the modern day large language model, there are several layers that finds the accuracy, that finds the relativeness of whatever the sentence which has been generated. So basically, the latter layers of the large language model is there for validation of the information by generating multiple prompt outputs and comparing them with each other and seeing whether the result is correct or not. So that's how these large language models are generating these responses. And we'll see another example now. So now in the screen, you can see we have an example of a code, right? It's a very basic for loop. So even the human mind would understand for this kind of a for loop, what's going to be the next part, right? It's obviously based on multiple combinations, based on multiple results, we would know it's going to be something like this, right? But if a specific requirement has been given, for an example, let's say generate a for loop, generate a number is of 1 to 100, right? It would know what are the paths that needs to be replaced. And out of the knowledge sources, it would understand what paths need to be replaced and the next tokens will be generated. So that's how these models are working, right? So I believe some of you all might have used this tool called tthe from Google, which works as a Google code companion, something similar to Copilot. So I think Copilot, of course, you all might have heard about the tool called Copilot, which comes from GitHub. So even Copilot works in that way. Basically, once you give the prompt, it would understand what the code is about, and then it will generate the next tokens. So tthe is also something similar to that. So now the tthe doesn't exist anymore because they release this code generation model to public as well. So now they have rebranded the entire tthe application into something else. And yeah, so that's how it generates the next token for the code as well. And the latter layers, it will compare with multiple generated outputs and it will validate the accuracy. But to mention that large language models are not fact engines, right? So we can't really rely on the exact output and the exact accuracy of the information, because these are not facts, because these has been mined from multiple sources online, and the results are given based on that. So we can't be 100% sure about the accuracy of these results. So we have to be mindful about that as well. Right. So like I mentioned earlier, modern day large language models are very large, right? Because these has been trained with millions of information sources available online. So it's not an easy task to train a large language model. We can't train a large language model at home, but we can fine tune it, right? But there are small language models also. So there are certain debates. There are several controversies going on between small language models and large language models with regard to the access of information. So, but I would recommend the fine tuning of large language models has been a significant improvement, as well as it helps a lot to build ML models in a way that we wanted. So yeah, like I said, it's very large, trained with a lot of information and sources. Right. So now that takes us to the capabilities of these large language models. So it not just generates text, right? So for an example, we can use these LLMs to extract data from paragraphs or documents or multiple sources. And also we have classification. So for an example, let's say if you want to classify information in a way that we wanted, we can even do that as well with the classification abilities of the large language models. And finally, we have summarization. We can even use this large language model to summarize content, text content, right, in that way. And also sentiment analysis. So I think sentiment analysis has been something common which came up few years back from a research paper. And the accuracy of sentiment has been much more higher with the introduction of large language models, because these LLMs have been trained with millions of data. So in that case, the accuracy of the sentiment analysis is much more higher when compared to the normal NLP-based approach. And finally, we have translation and the code generation. So you know what is it all about, right? So we have already mentioned about the code generation aspect. So all of these are the possibilities of the large language models that we have. So I know that all of you are competing for this hackathon called IntelliHack. So I think the expectation of this hackathon would be to come up with a working prototype at the end, if I'm not mistaken. So what you all can do is, right, so even if you're a beginner to machine learning, even if you're an advanced person, even if you're intermediate, don't worry about it. By using LLMs, by using the APIs of these LLMs, it makes you all to prototype fast. For an example, if you want to get something done in a way that it gives you predictions, it gives you results from these machine learning models, you can easily use these large language models to prototype fast. So don't worry, even if you are a beginner, if you're a novice, don't worry about it. You can even today you can get started. All right, so now let's talk about a very basic sentiment, right? So now we have a joke saying, I used to be addicted to soap, but I'm clean now. So now it says, as a prompt, it says, explain this joke. I used to be addicted to soap, but I'm clean now. So you can see this joke has two meanings, right? It has a literal meaning and it's a normal meaning as well. So it can have multiple meanings. So in this case, you can see it says the joke is upon on the word clean. It has two meanings, right? So now even these large language models can understand human language as well. So for an example, because these are trained with multiple millions of sources, in that case, these large language models has the capability of understanding the human language and to distinguish between what is the literal meaning and what is the normal meaning of this sentence, right? So in this case, you can see there are two meanings here: to be free of dirt or other wanted substances, and to be free of addiction, right? So in this case, you can see how the segmentation has been done in a way that the human mind, how the human mind understands these kind of sentences, and the prediction has been given in a way as that. Right. So if you take another example, you can see it says, give me 5 neat ideas for science fair projects, right? So talking more about large language models, we have two types of data outputs. We have something called structured data outputs and we have unstructured data outputs. So in structured data, what happens is, in unstructured data, what happens is basically, if you ask a sentence, for an example, in this case, I'm using this example called, explain this joke. I used to be addicted to soap, but I'm clean now. So you can see the model has been given the output as one sentence, right? So that could be a sentence, that could be a paragraph, or that could be some more output, right? So you can see the model has been given a large output. So basically, this is unstructured. It's a textual output. But if you have a look at this output, you can see it says, give me 5 neat ideas for science fair projects. So in that case, you can see all the output has been bulleted, right? And you can see it has a title, you have a description, and that's how the output looks like. So in that case, you can see the output has been structured well. So in unstructured, it gives you without any kind of formatting, right? Basically, the way that model understands how the result should work. And in structured way, we can explicitly say we can instruct the model to give the output in a way that we wanted. So for an example, if I wanted the output in JSON format, I can instruct the model to give me the output in JSON format. So if I want the output to contain a title and the description, I can clearly instruct the model to give me the title, to give me the output with along with the title and the description. So that's how I can instruct the model to give me the output I wanted, right? So basically with the prompt and the output, it gives me the output. So basically that's the difference between structured and unstructured data. And that takes us to this slide, basically on the capabilities of the differences of large language models along with the traditional approach. So if you talk about traditional NLP approaches, because those traditional NLP models are trained with limited number of data that does not have access to knowledge sources, because most of the NLP models are trained with a set of limitations. So in that case, it's not really okay. So to address the difference, I would say NLP approach, some of the limited NLP approaches are very important, but when compared to LLMs, this has access to massive amounts of information and massive amounts of data. So in that case, the outputs are really accurate when compared to traditional NLPs. But a lot of people are thinking, whether to apply these LLMs into their simple projects. For an example, let's say if you are doing very basic sentiment analysis, or whether you're doing a very basic information extraction. In that case, people are thinking whether to apply a LLM for this. So in that case, I don't recommend, because there are simple case if you require a higher accuracy. For an example, if you're building like conversational chatbots, if you're doing something like advanced search, so in that case, we might require LLM. But there are certain scenarios that can be done with very basic NLP approaches as well. So I have seen people are applying LLMs to anywhere, right? Even if it's a very basic text extraction, even for a very basic text summarization, people are applying LLMs everywhere. So that doesn't require. So when you are developing projects, we should understand whether to apply LLMs or not, right? So that's totally in our hand. So we should know where to apply LLMs and where not to apply LLMs. So now if I take these three examples on search and conversation and content generation, right? So now the search results, the searching of information has been much more advanced. So for an example, it doesn't matter how dynamic your information is. It doesn't matter how dynamic your content is. Still, you can search content based on the knowledge facts. Knowledge sources it has been given. And then we have conversations. So you guys might have seen a lot of chatbots that are coming up in the near future. So development of interactive chatbots and development of dynamic chatbots is much more easier nowadays, because these chatbots can support multiple dynamic conversations and dynamic outputs. So in that case, I would say development of the chatbots has been made really, really interesting, and it has been made human sounding. It sounds like a human if you build a chatbot using large language models. So earlier days, I'm talking about few, let's say 4 years back or like 5 years ago. So we had platforms such as Dialogflow, Rasa, and these kind of platforms to build chatbots. So I would say in most of these chatbots, that you guys saw on Facebook and all, those are like fixed chatbots, right? So basically we had to go through options and we had to choose the option, and then it gives you the response, something like a menu kind of thing. But nowadays, we can interact with these platforms in human language. So for an example, you want to make a booking, you want to make a reservation for online shopping and any kind of use case which is supported with these models. So that responds to you as a human. And then finally, we have content generation. So not limiting to text data. So that even supports images as well. So like I said, it can generate text, it can generate images, audios, videos, right? Multiple sources are supported. So that's how these models are made, and so you can actually imagine the advancement of these technologies. Right. So now let's talk about a bit of history. So starting from 2015 and towards 2024. So, Google has invested in this project called Google DeepMind, and they came up with this AI called AlphaGo. And you can see even defeats a Go champion as well. So there's this game called Go. So if you haven't seen, you can just make a Google search and see. It's a very basic game, something like Monopoly, a kind of thing, but it's not in that caliber. But there's a game called Go. So in DeepMind, they made this first AI, and yearly they made huge improvements. And here we are right now with the development of Gemini. We are at this stage at the moment. And earlier we had something called Palm 2. And along with the Palm 2 also that has been a significant improvement as well. These where they introduced most of the generative AI tools along with the Google Bard. And so now we have final Gemini. So now the Bard is not being properly used. So now we are in the Gemini era. And also with that being said, I want to talk about a few things about responsible AI as well. So, there are a lot of use cases in terms of GenAI. So I know a lot of people are using these GenAI tools to ease their day-to-day work, but there's something called responsible AI. How are we going to use this tool how are we going to use these GenAI tools for the betterment of the human being rather than using it to destroy the human being? So we are supposed to use it responsibly, right? And how are we going to address issues like privacy, and how are we going to make sure that the outputs of these models are human friendly, right? Because we know these models, we know that these models are having access to information which is human friendly and not friendly, right? And some of the information can be explicit content as well. So in that case, we had to make sure on how are we going to cater the output to the human, right? So in that case, we had to introduce additional layers, and we had to do some additional validation. So that comes under responsible AI. So I would say, if you guys are into research, I would say responsible AI is one of the most trending, most emerging topics that you all can research in. And these are some of the areas that you can look into, right? So basically, it's not all about building the model, but we have to make sure the outputs are going to be much more helpful for the human being. And also, how are we going to address these issues such as privacy and accountability and safety, right? These kind of factors. And yeah, so let's move forward. And now that takes us to multimodal, right? So those who are not familiar with multimodal, I think all of you might be familiar with, most of you might be familiar with LLMs. But now with the introduction of Gemini, now we have something called multimodal. So what is multimodal? So basically, multimodal is all about not just processing text data, right? So multimodal supports multiple input types such as text, audio, images, video, and out of all of these input sequences, the multimodal ability can, along with the transformer they have built, this can make a combination between all of this information. So for an example, regardless of whether if it's text or whether if it's audio, video, or images, the multimodal capabilities can make a combination of information between all of these sources. And with the transformer they have made, we can get meaningful results, right? So that's called the multimodal. So now if you have a look at the search engine such as Gemini, the tools such as Gemini, it supports multimodal. So we can even upload image and we can ask to describe what this image is all about, right? And so in that example, we can see we are giving the text input plus we are giving the image input. So that's how the multimodal capabilities are working. And then we have another model called Claude. If you guys haven't heard about Claude, you all can make a simple Google search. So that is also pretty good, I would say, compared to Gemini. That goes head to head to Gemini as well. There's a model called Claude that also supports multimodality. That we can even interact with images or text content. I'm not sure about videos and audio, but Claude, of course, supports images and text content. Right. So now finally, we are at the era of Gemini, right? So we have come a long way from AlphaGo to Gemini from Google. So now we are at the age of Gemini. So before I move forward, let me quickly go to the website and let me introduce you some of the concepts of Gemini and how we can use it and what are the different plans available, and let's see what are the stuff which is there in their website. Right, so if you make a simple Google search for Gemini, you will you will get to this page. Just make a simple Google search called Gemini. And here, under this page, you can see there are a lot of information. So you can see we have multiple versions of the model. We have something called Gemini Ultra, Gemini Pro, Flash, and Nano. So first of all, let's describe the differences between these models. All right. So basically, the largest model of Gemini is called Gemini Ultra, right? So when compared to the performance and the availability of the information, the Ultra has the largest scope of information available, and it has been trained with a lot of parameters when compared to the other models. And then talking about the memory complexity, and in terms of the pricing also, this is a bit more expensive when compared to other models. And it takes higher memory as well when running it on their servers. And then we have something called Pro model. So I would say when compared to Ultra model and Pro model, if you are using it for general tasks, I would say Pro model is ideal tool that you all can use, and which uses less memory when compared to Ultra model, but with less information. And then we have the Flash model. It's a lightweight model that you guys can use for very generic tasks. For an example, so in that case, if your application is a very basic application, it doesn't have to go with Ultra model, right? So you can either choose between Flash model or the Pro model. So it's all up to you. You all can decide based on the application. You all can decide which model to go ahead with and which model to choose depending on your use case. And finally, we have the Nano model. So for an example, this is applicable for tiny ML kind of applications. So for an example, if you are doing edge-based, edge computing-based kind of task, and on-device machine learning, you guys can use the model called Nano. It's a very lightweight model that you all can use it for your day-to-day tasks. And then we have another series of models called Google Gamma. Right, so there is another series of models that we can use for a lot of tasks. So basically, Gemini is cloud-based, hosted on Google servers. And then we have Gamma models. This is actually open source, something similar to Llama 2. And this is actually very accurate as well when compared to Llama 2 models as well. So under Gamma model, we have a lot of other submodels as well. We have something called Gamma, Code Gamma, and Polygamma. So basically, talking about these models, Gamma is the generic large language model. And then we have the Code Gamma, which is capable of generating codes for developers. And then we have the Polygamma, which is the image model, the open image model, and the recurrent gamma. So it's a neural network based model. So in that case, these are the different types of Gamma models we have. So if you download the Gamma model, you can set this up in your own servers, maybe your local servers or even dedicated servers, but it consumes significant amount of memory. So I would say it's up to you all. So if you are into local, if you are deploying these machine learning models locally, you can use Gamma model instead of using Gemini. So it's up to you. Depending on your use case, you can use it. And then we have, so you can see the performance when compared to Llama 2 and Gamma, right? So you can see the Gamma 2 has been trained with 7 billion parameters, and even Llama 2 has been trained with 7 billion parameters. So you can see how these performances are there when compared to these other models. So you can see different types of benchmarking has been given. So you can easily compare and see. You can see in most of the benchmarking aspects, Gamma is ahead of Llama 2 and Mistral also. In some of the aspects, it's lower, but in most of the aspects, compared to different benchmarkings, Gamma is performing much more better. So that's it about Gamma. So I won't be talking much about Gamma because it takes us to another topic of discussion. So I'll stick to Gemini for the model and Gemini for the movement, and I'll talk more about it. Right. So if you're interested in learning about Gemini, you all can go to this website and you all can see what are the capabilities of Gemini, and what are the different benchmarkings they have done, and along with the benchmarkings, which are the results that they have compared, right? So in that case, you can see the Ultra model has the highest score, but Pro model is also performing really well when compared to Ultra as well. So, but in terms of the language, in terms of the knowledge access, Ultra is doing much more better. Right. Okay. So let's discuss about multiple use cases now. Right. So now talking about Gemini, it has multiple target audiences for consumers, for developers, and for business and enterprises. So I believe all of you have used these Gemini personal assistants. So if you go to gemini.google.com, you can access their personal assistance service, something similar to ChatGPT. You can ask anything. You can ask this tool to generate emails, generate text, or whatever things which is supported. So this is more like the consumer end of Gemini. Anyone could easily use as ChatGPT. And then we have Gemini for Google Apps. For an example, Gmail. You all might have seen this feature called Smart Compose. So basically, when you're writing the email, it completes the latter part of the email. That's using this feature called Smart Compose. And then we have the Gemini in Google Docs and Google Slides as well. In Google Slides, they have recently introduced this Gemini, where it is capable of generating slide decks, right? So the moment we ask Google Slides to generate something, it generates the entire slide deck for you. So those kind of features are there in Gemini. And then we have, so we are talking about developers. So this slide deck is all about for developers. So we are using the Gemini API. So we have this tool called Google AI Studio. So here we are going to do the experiments on top of Google AI Studio. And along with that, we are going to use the Gemini API. So finally, we have Gemini for businesses and enterprises. So you all might have heard about this platform called Google Workspace, which is previously known as G Suite. So we can even install these Gemini capabilities on G Suite, and we can use any of the operations, and we can easily integrate between the G Suite package from Google, and we can use it for business cases. For an example, scheduling of meetings, taking meeting minutes from Google Meet, right? Things like that. We can easily use Gemini for business end as well. And finally, we have this platform called Vertex AI. So I think I have discussed more earlier in my earlier sessions. I have discussed about Vertex AI, which is the AI platform of Google. So we'll talk about that as well today. Right. So anyway, before I move forward, I want to know if there's any questions before I move forward to the next segment for today. You all can use the chat section. If you all have any questions, you all are free to ask, you all are free to share. Right. Are there any questions so far? Right. Okay, there's a Padlet link. Right. So if there's any questions, you guys are free to use the Padlet link, and or use you all can use a chat section as well. So yeah. So far there's no questions. Shall we move forward? Organizing committee.
Yes, we'll move forward.
All right. All right. So until that, you all can send in a question. So I'll answer those in the midday of the presentation. Right. Okay. So now let's do something hands-on. Right. So to interact with the Gemini API, we have this easy-to-use platform called Google AI Studio, right? So those who have heard about Google AI Studio, can I see a raise of hands? Right. Couple of people. Right. Very few. Okay. Perfect. So let's get started. So now to work with Google AI Studio, you all can just make a simple Google search and that takes us here. Right. So now it gives me the option to sign in, right? So right. So it gives me an option to sign in from here. So I'm going to sign in with my Google account. Right. So now this is how the interface of AI Studio looks like. So now from here, what I can do is I can get an API key. First of all, I had to request the API key from Google Cloud. So I can click on this, and then I can click on create API key, right? So right now I don't have any other API, any other GCP project. So what I'm going to do is I'm going to GCP console, and then I'm going to create a new project. Right. So from here, I'm going to create a new project called UCSC workshop. Right. So I'm going to select it. And finally, you can refresh this and right. Seems like I have to enable the APIs. So what you can do is from here, I go to Vertex AI and search for Vertex AI. And here, from here, you can click on enable all recommended APIs. And what happens is it will enable all the access to generative AI features, and you can easily use it. So it takes some time. So until it loads, I'm going to use my default projects, which is called generative AI language client. So I'm going to use my default project until that loads. Right. So from here, you can click on create API key. Right. So now we have API key, right? So you all can store this API key in a secure place because we are going to use it for the coding tasks that we are planning to do. So you all can just copy and paste it for the moment. So anyway, before I proceed with my coding tasks, let me talk about the different types of SDKs available and different types of languages that we can and the APIs that we can use. So talking about the Google AI Studio, it supports all of these frameworks. It supports Python, Node.js, Swift, and Java. And also it has a REST API. So if you're making API calls, if you are using any other types of languages, you can use their REST API to communicate with their client and to communicate with their generative AI APIs. So other than that, we have these SDKs for Python, Node.js, Swift, and Java. So don't be worried about if you're using any other languages such as Golang or any other thing. Don't worry about that because you can use their REST API if you want to make any API calls. Right. So now let me quickly talk about Vertex AI also, as I mentioned about you all about that. So Vertex AI is more like the enterprise edition of the Google AI platform. So which was previously known as Google AI platform. Now it's Vertex AI. But there are a lot of benefits of using Vertex AI for ML tasks. So now if I go back to Vertex AI, if I go back to my Cloud Console, you can see that even Vertex AI has a lot of features, such as it has all of these models, the multi-model access, and also it has Gemini as inbuilt. But if you're planning to use it for complex tasks, for an example, if you want additional rate limiting, if you want secured access, if you want any kind of IAM related access, you'll are free to use Vertex AI rather than AI Studio, because AI Studio is mostly for beginner level tasks, and it does not have any kind of access levels or access controlling. I would say if you're into enterprise, if you're building enterprise grade applications, I would say using Vertex AI is a better choice when compared to the AI Studio. So in that case, you all should know where to use Vertex AI and where to use the AI Studio. And talking about Vertex AI, it has a lot of features such as you can build the you can build the entire MLOps lifecycle on top of Vertex AI. Starting from data gathering to the model deployment, you can handle the entire workflow on top of Vertex AI, right? So in that case, this is pretty much the advanced version of the Google AI Studio. But as for this demonstration, we'll be using the Google AI Studio in this case, right? So before I move forward, give me a few seconds. Right. Okay. So now we'll move forward. Let's talk about some of the usage patterns of Gemini. First of all, we have the basic prompting. We'll be talking about some of the prompting basics, and then we'll be talking about code generation and search and retrieval of information and function calling. So function calling is one of my favorite options. So I think the intermediates and the experts, those who might find it boring in the first segment of the presentation, I believe function calling and the RAG approach and the tuning part is going to make your interest. So I'm pretty sure that because function calling is one of the most interesting features that is there on Gemini. So I'm pretty sure that it's going to be you all might find it interesting in these sections of the presentation. Right. So before I move forward, I want you all to I'll give you all a minute to scan these QR codes, and you can get access to my repositories and the Gemini cookbook. So I'll give you like a few minutes to access these repositories, and you all can take pictures or you all can take screenshots, and you all can get access to it. Right. Okay. All right, so I believe you all have taken the screenshots and taken the links of these two repositories. Shall we move forward? Organizing committee, shall we proceed?
Yes, we are good to go ahead.
All right. Okay, so so we have few questions. We have one question. What are the tools and technologies you want to be a machine learning developer, and which type of projects you want to do? So it's actually very generic questions. It's a very generic question because there are a lot of areas in machine learning. So we have NLP, and taking that into advanced level, we have large language models, and then we have something called image processing. And there are a lot of levels. There's deep learning, right? So we have different types of machine learning projects, different machine learning types. So it depends on what is the area that you want to master in. So in that case, I would say you might have to rethink about what is the category that you want to go forward with. But as a beginner level, I would say start with, so if you're interested in NLP, I would say if you're interested in large language models, I would say better to start with NLP, right? So if you're interested in learning about the core of the large language models, if you're interested in learning about the fundamentals of the large language models, I would say you can start with NLP, very basic NLP, and then you can come to transformers, and you can learn about few concepts such as vectorization and these kind of things, and then you can come to large language models as well. But if you're interested in learning image processing and deep learning kind of thing, there are different paths. I am free to I'll share those things. If you can message me personally on LinkedIn or some other social media, I'm free to share the pathways with you. So depending on whichever the path that you want to go into, there are different pathways because it's every single area is different. So you can decide upon which path to go for, and depending on that, you can think about I can give you the guidance on how to start. Right. Okay. So now, first of all, let's talk about some basic prompting. So, right. So now again, if you have a look at this example, you can see it says, write a poem about a magic backpack. So earlier also I mentioned that. Right. So earlier also I mentioned that we have two types of information. We have something called structured data and we have something called unstructured data, right? So in that case, let's say in this example, it says, write a poem about a magic backpack. So you can see it has generated this output. It says, in a world of wonder, behold, a backpack with tales it untold, right? And let me give you another example. So let me do it in a way that you understand along with AI Studio. Right. So now under the AI Studio, you can see there's option saying create a new prompt, right? So you can see once you click on that option, it gives you two options. The first option is called chat prompt and the second option is called structured prompt, right? So if you're looking at unstructured data, like I said earlier, you can use the chat prompt, but if you're so now you can see I have given this example saying write a poem about a magic backpack. So each time it's going to give a different result, right? So it's not going to be the same result all the time because it's generating new creative outputs. So now the specialty about this model is that you can make these API calls with the API they have given. So for an example, let's say if you want to get this result, in your own application, you can simply make an API call. So now you can see in the top right corner, we have this option called get code. And depending on your language and depending on your own technology, you can use whatever language you prefer. And based on that, you can generate the code of it. And you can easily use this. You can easily get these results within your own application, right? For an example, let's say in this case, if I'm using Python, I can use the Python SDK, and here I can pass whatever the you can simply pass whatever the inputs, and you can get the result very straightforward. And you can even set the configurations from here. You can see we have several configurations called temperature, top P, top K values, and the max output tokens. And we can see there are multiple configurations that we can set. So we'll discuss about each of these configurations now. Right. So now you can see it's an unstructured thing. So we are allowing the model to freely think, right, without giving any constraints. So that's called structured way. And then we'll talk about something we'll talk about something structured now. So earlier, the previous example was unstructured, which means we are allowing the model to freely think. And then we have the structured example. So we are giving some constraints to the model where the model can think, where the model has to stay within our constraints. And when they are producing the output, the model has to give the output in a way that we wanted, right? Not as the way that model wanted, in the way that the human wanted. So now you can see it says generate a short tip about JavaScript. Good tips are short and contain code example, short tip, right? So in this case, you can see it says generate a short tip about JavaScript. Good tips are short and contain code examples. So in this case, you can see, so since we are instructing the model to go for a further step, you can see it saying it gives me the tip plus the output board. So this is more like structured. So we are instructing the model to work in a way that that we instruct. So right. So now you can see that in this example, right? We have this is a code example I mentioned, right? Without just mentioning the output of the model, I'm saying along with the output, along with the tip, I'm asking the model to show me a code example. So here you can see for the structured data, I have given the topic like this, and then I have given the tip like this. So you can see in the examples of we are giving some examples to the model, right? So without blindly saying these are the output I wanted, I'm giving some examples to the model saying this is how I wanted the outputs to be. So in this case, I have given 3 examples to the model saying that let n constant, it has to be the output something similar as this. Arrow syntax, it has to be something like this along with the example, and template strings, it has to be an output like this. So basically, I'm instructing the model to give me the outputs in a way that I instruct, right? So this is called the structured way. And right, so now let's see an example. So now I'm going to do this example on top of the AI Studio. So now if I go to create new prompt and structured prompt, so this is where I can give my examples. So for an example, let's say I'm going to try something different now, right? So for an example, let's say I want to make an application about animal breeds, right? So in that case, let's say so basically I'm going to I wanted to get the data as a structured way. So in that case, I'm going to input some names. So let's say dog. So here I can give the output. I can structure the output here. So for an example, let's say I can say output as JSON. So let's say I wanted to get the animal breeds as the moment I send in the input of the animal, right? So for an example, in this case, I'm going to give some outputs. Golden Retriever, and let's say Pit Bull. Let's say Bulldog. Right, so that's enough. And then let's give another example. So I'm giving an example. Let's say okay, so I want to find out some animal breeds right now. So let's say Ragdoll. And let's say short hair, right? So I'm going to give some examples over here, and then you can see we have the input and the output, right? So basically in the way that it instructs, so I'm going to give an input here. So basically I'm going to say fish. So for an example, I want to get the output of the animal breeds of the fish. So if I run the program, you can see by understanding the output of the input of all of these by understanding the input of all of these examples I have given, you can see it has given me the output of the fish as well. So I can even structure this in JSON format as well. So we had add some additional quotes to make it to get just this output. So I'll show you that as well. So basically you can see based on the examples I have given, you can see it predicts the next output of whatever the example I have given. So depending on the examples I have set from here, it gives me the most suitable output. But so you can see this more structured approach. So we can even get the code of this very easily, and we can run this in our local environment, maybe Python or JS or Android or Swift or even API curl API calls are supported. So right. So now let's see some other examples also. So this is how you can integrate the model to your application, right? So we are using the Python SDK, the Google Generative AI Python SDK. So here you can see we are using the package called GenAI, and we are using this model called Gemini Pro. So when talking about Gemini Pro, there are several limitations in the other models also, Gemini lightweight models and the Gemini Flex model. There are several limitations. So in this purpose, I'm using Gemini Pro because I want to set some constraints. So in that case, if it's like an unstructured data, you are free to use Gemini Flex as well. But throughout the entire presentation, I'll be using Gemini Pro because to address some of the limitations of the other two models. Right. So now this is very basic. In this example, you can see it's more like a very straightforward response. So you can see very easily I have import the model over here, and then I am passing the content that requires to be generated. And then at the end, along with the print command, you can see I'm getting the output over like this. So this is more like a very straightforward approach, like duplex approach. I'm sending the output and I'm retrieving the output. And now that comes to chat threads, right? So you know the difference between chat threads and the normal thread is that in chat thread, we can interact with the response. So for an example, we should be able to send follow-up responses, right? So in this example, we can't send a follow-up response to my model, right? But if you're building something like a chatbot kind of thing, we should be able to ask follow-up questions. So we should form a chat thread in that case. So what we can do is you can initiate a chat. We can initiate a chat thread like this, and then you can easily pass a message to your chat thread, and then you can even get follow-up questions, and you can even follow up. You will get follow-up answers as well. So depending on the historical data, depending on the chat history, it will give you the responses based on the entire chat history that you are building, right? So this is called the chat message. And in this example, you can see. Basically, you can see there are multiple layers of text information, and this is how the chat thread works. So you can see, first of all, the user is sending some information to the model, and then the model responds to the user in text format, and again, user is sending back some information. So in that way, the chat thread would work. So not just text information, the user is able to send in images, and also, like I said, audio and video and those kind of information also the user can feed into the model. So right. So now I want to talk about few other prompting examples also. So we have 3 ways of doing this prompting. So nowadays we have this new industry, we have this new job role called prompt engineers. So that's also a new job role. So with the along with the generative AI development. So we have this new job role called prompt engineers as well. So now talking more about prompting, we have three ways of constructing the prompting. The first prompting approach is called zero-shot prompting. Second one is called one-shot prompting. And the final one is called few-shot prompting. In zero-shot prompting, what happens is we are providing a command to the large language model without any example. So same as what I did here in the early example, I just asked the model to write a poem, right? So in that case, there was no examples. The model is capable of thinking by its own, and the model can create you to think anything, and they can give you the result, right? And then that comes to our one-shot prompting. So in one-shot prompting, I can give an example thing. So for an example, I can say, generate a poem about this topic by mentioning about certain parts, right? So I can give one example in that case, maybe like a one example poem. And then based on that, it will understand the tokens, and it will give you the output based on one example. And then we have something called few-shot prompting. So here what I did was, in this example, I have in this demonstration I have shown you all. You can see that I have given 2 examples. So I have given the output structure in 2 ways. So you can see for dog in another way. And then we have for cats in another way, right? So you can see based on this, it gives me the result in a way that I structure the data. So that's called few-shot prompting. So if you are interested in learning more about these prompting approaches, you all are free to access this page, and it gives you a lot of strategies to design these prompts. And at the end of this presentation, I can share this slide deck with you all, so you all can have understanding on all of these topics. Right. So now let's talk about one more parameter that you all show here. So you can see there's a parameter called temperature, right? So we'll talk about what is this temperature is all about. So now we have this. So let's say we have a sentence such as, let's say we have a garden. We have a garden full of space, right? So we'll take that example. So to fill that space, there can be multiple combinations of words, right? So you can see we have the combinations as flowers, trees, herbs, and bugs, right? We can have multiple combinations of word to fill that missing word. So in that case, you can see for each word, we have some kind of a percentage, right? So basically based on multiple inputs that has been given to the model based on multiple combinations, you can see the garden is full of flowers is having the highest possible prediction rate. And then we have trees in the second place. And then we have herbs, bugs, right? Because these are very highly likely depending on multiple information patterns that has been fed to the model. These two are very highly likely, right? So, but the garden is full of bugs is very highly unlikely. So basically you can see the temperature, if you set a higher temperature, the more the randomness that you get, right? So if you want more creativity from your model, for an example, if it's like a poem generation kind of thing, we might need a lot of randomness. We might need a lot of creativity. So in that case, we can increase the temperature of the model to the most highest level. But if you want the model to be very specific, very niche, and very accurate, in that case, we have to decrease the temperature, right? Because in that case, the randomness would be very much low. So for an example, in this case, if I set the model's temperature to the lowest point, what happens is all the time, the output of the sentence would be the garden is full of flowers, or maybe trees as well. Because the trend, because I have removed the temperature, I have made the temperature to 50%. In that case, it will only capture these two values, right? Out of the entire bags of words, it will only capture these two values, and the randomness of going to lower results will be the chances will become much more lower. Going to the lower results of herbs and bugs. So you'll always capture flowers and trees in that case. So you can see how the accuracy is going increasing based on the temperature I set from this parameter. Right. So now let's see that in action. So now I'm going to create a new prompt, a unstructured prompt. So I'm going to ask this Gemini to write a poem about GDG. Write a poem about GDG Sri Lanka. So with the temperature of maximum level. So now let's see what kind of output I would get. Right? So you can see it gives me a very creative poem. It says beneath the sun warm, island grow, where coconut plant. So you can see it has very creative words, right? Creative way of expressing whatever the content that they want to generate. But if I decrease the temperature, now let's see what kind of output I would have. So now I'm asking the same question from the model. Right. So now you can see. So without writing these kind of random things, right? So you can see it's going to be very specific, right? It's going to be very specific. It's going to be more dev oriented, right? Because it's going to use very limited number of bags of words. So in that case, the more the variance would be less. So you can see using the specific stuff that GDG is doing. So you can see the poem has been generated. So you can see it's all about the tech community, and it's all about code and the tech stacks, and you can see how it generates the code. But here, if you have a look at this example, you can see it's talking about sunswarm and island grow and Candy's hill. It's more like a random, it's very creative poem because I have set the temperature into the maximum level. So in that case, you can see it's talking about a lot of things, and the scope that I want to cover is very low, but it's being very creative in this context. So that's all about the temperature. So let me talk about some other stuff as well. So now let me, if you go to my repository, if you go to my Git repository, I have given a very basic example called basic prompt. So in this example, you guys can see how to set up a very basic Python application. So here I'm using the GenAI SDK. Okay, so in the basic prompt application, I'm using the GenAI SDK, and then I'm using the .env to retrieve my API key. And this API key can be retrieved from your Generative AI Studio. So if you click on Get API Key, from here, you can easily copy and paste this API key, and then you can replace it maybe in your env file. You can use that in your environment variable file, right? So you can just replace this in API key based on the API key that you get from the AI Studio. And then if I go to basic chat, you can see I'm using this model called Gemini Pro. So this is where I load the model. This is where I load the model. So even if you're using another model such as Gemini Flex or Gemini Lite, you can import that from here, and you can basically start. So I'm using the basic chat prompt here, basic prompt here. And yeah, so you can see this way I feed the response, and this way I print the response. And finally, like I said earlier, we have the chat prompts as well. So if I want to provide any follow-up questions, or if I want to get any follow-up responses, I can use the chat prompts, and I can initiate a chat like this, and I can basically send in some responses, and I can also get the responses. So basically, I can ask follow-up questions continuously. So based on the context, it will keep giving you the answers that you want. So all of these sources are given. If you go to my repository called Gemini Workshop, all of these sources are given. So you all can go through the code bases, and you all can have understanding on how to how to work with the Python SDK. Right. So now, but let me run this code and show you all how it works before. So I'm going to use this basic prompt application. So here, what I have done is basically I have asked write a first paragraph of a story about a magic backpack, right? Right. So now let's see what kind of output I would get. Right. So you can see it's calling the Gemini API, and it's getting the output like this, and it's printing with my print statement, right? It's very basic. It's a very basic application. So I think all of the beginners can get started with it. So without putting additional hassle, even the beginners can get started with it. So it's a very basic application. You can see I just passed my prompt, and based on the prompt, I'm generating the output. Right. Okay. So next capability, let's talk about code generation. So I'm pretty sure that all of you might be familiar with applications such as Copilot, GitHub Copilot, so which is capable of generating source codes. So that takes us to Gemini also. So we have multiple, there are multiple use cases that we can use. So for an example, in Gemini, we can generate a code based on user prompt, and also we can simply convert human language into code, into machine request, and then we can use it for rapid tool building. So for an example, even if you're making some kind of code builder, you can use Gemini model to generate code of your application. So now let's see a very basic example. So in this example, I'm asking the Gemini to generate a table that has all the countries in the world listed alphabetically, their capitals, and what continent they belong to. So you can see Gemini has generated this table. So it has 3 columns: country, capital, and the continent. So you can see it has all the countries sorted in alphabetical order, and the capitals and the continent. So you can see, so even if you are building data sets, I would say you can use it, but it's not a reliable source. I would say, first of all, I have to give that caution. it's not 100% reliable, but we can use it for some extent, right? So here you can see, based on the input, it has generated this entire table. And then I'm asking, generate a SQL query that will query for capitals of countries of Asia following this format: table countries, columns. So I'm defining what are the columns that I want to retrieve. And so you can see basically, depending on the instruction I have given here, it generates me a SQL query, right? So this seems very straightforward, right? So you can even do that with ChatGPT. You all might be thinking, right? So what is the purpose of doing that with Gemini, right? So here's the interesting thing. So now we have the data and we have the SQL query. Now we can simulate and see how the result comes, right? So you can see basically based on this. So then my next question is basically, what is the output from this command and table? So now I have the data and I have the query, and I'm asking what is the predicted output by executing this kind of a query on top of your table, right? So you can see it will run this query, it will give me the output based on this SQL query and the data set I have given. So you can see how advanced this model is, right? So see, you can see the capabilities when compared to GPT-4 and this model. As you can see how capable this model is on understanding certain things and on providing results on multiple criteria. So this is how powerful the model is, right? So right, so you can even use this model to ask to generate Docker files, anything, right? For example, functions or any kind of code snippets. And it will generate for sure, but you have to make sure that you are being very specific on what are the inputs that you're giving and what kind of setup instructions you are giving. So based on that, it will generate whatever the output that you wanted. So in this example, let's see how we can use this capability in the industrial grade, right? So now we know that sometimes you all might be thinking, right? So we can easily get this thing done by ChatGPT as well, some of the aspects. But now, how are we going to use it in industry? So you can see we have a function call, we have function call is driver neutrally behaved. So you can see in this case, what happens is I can ask Gemini to write unit tests. So if you are having multiple Python functions, we don't have to write unit tests manually, right? We can just feed the Python function to Gemini, and we can ask Gemini to write unit tests for these functions, right? So in that case, you can see it will automatically generate these kind of functions by evaluating the code. And you can see with the assertions, it will generate the results of the entire function. So this is how you can use this code generation capabilities in the industrial grade as well. So without putting much more human effort into code, in this way, you can automate the entire QA flow as well. So if I into QA automation fields as well, you all can think about how you all can utilize Gemini to automate the QA field as well. Right. So now we'll talk about the search and information synthesis. So now we know that most of these large language models are having information cutout. What I mean by that. So, all right. So anyway, I want to I want to go back to my Q&As and see if there's any questions I have gotten. So before I get started, let me see if there's any questions you all have gotten so far. So far, no questions. Right. Okay. Okay, I have a small request to speak slowly. Okay, definitely I'll do that. Yeah. Okay. Right. So I believe so far no questions. Right. So we'll proceed. Right. So now BYO data. What is that? It's called bring your own data, right? So something similar to BYOB, bring your own boost, right? We have BYO data, bring your own data, right? So when talking about large language models, these models might have access to public data, which is already there on the internet, right? Because the data mining has been done along with the public data available. But in that case, these large language models might not have access to our internal data. So I'll give a very basic example. So for an example, let's say we are building an application, we are building an industrial grade application, which can access our internal user guides, and it can understand the user guides. And based on our questions, it should be able to give you the output, right? So in that case, the large language models might not have access to your private user guides, right? Because these are confidential information of the company, right? Which is not being exposed to anywhere in the internet. So in that case, we can bring in our own data to large language models to give the output in a way that the information is structured in our own information sources. So for an example, that could be the handbooks, that could be maybe the user guides, or any kind of private information can be taken into the model, and then we can use that to that as a knowledge base to answer the questions, right? And the second point is, like I always say, LLMs are not fact engines, right? Because we can't hunt available in our hands. So in that case, we have to be very specific on what kind of information now we feed into the model, and how are you going to feed the model with the accurate information that we have in hand. So, and the third point is basically no exposure to private data. Like I said earlier, the models might not have access to public data. So in that case, we have to give access to our own internal information, right? So in that case, we had to provide with our own internal information. So basically, let's see how we can do that as. So we have several questions. Can you give us the slides? Of course, at the end of the presentation, at the end of the workshop, I'll be giving the slide link. And we have some interesting questions also. Will AI replace humans' role? Yeah. So those questions I'll address at the end of the presentation. So those are like philosophical questions. So free to answer those as well. So at the end of the presentation, definitely I'll answer that question. So then we have another question saying how to fine tune to answer based on a PDF document. Yeah. So that's the example that I'm going to do right now. Right. So now let's see how are we going to feed the context, right? So now it's all about structured data I'm talking about. So now we all know the difference between structured and unstructured, and what are the constrained information that we are going to take place. So let's see how are we going to structure the prompt. So first of all, we have the instructions in hand, and then we are saying, okay, model, this is my information, and I want you to give the answers based on this piece of information, right? First of all, I'm giving the instructions, and then I'm giving the context, right? So these are the this is how you should give me the responses, and this is the context that I want you to go through, and I want you to give me the results. So instructions and the context, and finally I can ask the questions. So basically, I can ask follow-up questions saying, yeah, now that the context has been provided, I can ask follow-up questions to get to know the information. So let's see how we can implement that. So I'm going back to my code base. So now if you go to this file called information retrieval in my repository, you can see that I have defined my model and the API keys over here, like I explained earlier. And then here, what I'm doing is I'm passing my document, right? So you can see I have a very basic text document I have passed to this model. So you can see this text document is having a very basic summary about the GDG Sri Lanka. So you can see it says GDG Sri Lanka is a community of tech enthusiasts. And you can see it's a very basic summary taken from the website. And then if you go back to this, it says generate content. And you can see, and here you can see basically, this is a question that I'm asking. And here I'm giving the instructions, and you can see I have passed this document as well. So I'm taking the entire text content of this text file, and then I'm passing that into my model like this. And at the end, I'm getting the result. So let's see how it works. So you can even do this with PDFs as well. In PDF, there are certain Python libraries, PDF to text library that you can use to extract the text content of the PDF file. With that, you can extract the content of the PDF file and you can feed into this, and you can get it done. And also we have the RAG approach. So at the end of the slide, I'll talk about the RAG approach as well. For this very basic approach, I'm trying to do the information retrieval. Right, so I'm going to execute this Python file. Right. So now my question is called, what is this organization? Right. So now you can see information I have passed is basically a very brief paragraph about GDG. And you can see the response, it says, so my question is called, what is this organization? It says Google Developer Group Sri Lanka. So now I can keep asking more questions, and it will give me the outputs based on the information I have passed here. And you can see the instruction I have given here is basically please answer based on the following document. So in that case, by having a look at the text content of the document, it will give you the answers that you want, right? So that's how we can feed in our own data, how you can feed in your own data to your model. Right. So, right. So I think I have already discussed about this point. And now let's go to a small comparison. So I have already mentioned that the Gemini is capable of understanding contextual data. So what I meant by contextual data is that, so for an example, even if it's a 1 hour long video, even if it's a huge text information based on 30K lines of code, 30 lines of code file, and also it can understand the context by analyzing even 700K words, right? So Gemini is very capable of understanding contextual data when compared to any of these models, such as Gemini 1.0 Pro and GPT-4 and Claude as well. So you can see how better it's performing when compared to all of these models. So you can see it can understand any of these contextual information, and it's performing really well. Right. So based on whatever the information you feed, even if it's a very long video of 1 hour, it can understand the context with the highest accuracy level. Right. Sounds good. So now let's move forward to the most interesting part for me. So now we have something called function calling in Gemini, right? I'll take a small example. So let's say you are given the task of creating a chatbot for a restaurant, right? Let's say you are given the task of creating a chatbot for a restaurant, right? So this chatbot is supposed to ask questions from the user and understand what the order is all about, right? And finally, the chatbot is responsible on asking any additions, if there's any quantities, or if there's any other additional information. And at the end, the chatbot is responsible on placing the order as well, right? So, you know, it's a very complicated process. It's a complicated process because that involves a lot of APIs also. For an example, if you're working with a kitchen kind of system, the model is supposed to place the order in their POS systems because they might be using third-party POS systems. So in that case, we might have to interact with the APIs, right? Sometimes we might have to work with their booking systems. So for an example, let's say if you're making a chatbot for a hotel reservation platform, we might have to interact with their with the internal systems to make the reservations and bookings, right? So in that case, we have to work with third-party internal tools and third-party external tools and APIs and different types of function logics. So with Gemini, we can do that as well because Gemini has the contextual understanding, and Gemini we can easily make function calls with Gemini very easily. So let's see how we can do that. So now let's talk about this example. So you can see the user is asking a question such as, what percentage of orders are returned, right? So if you have a look at this example, can the model understand this question and give the response based on a fixed knowledge source? So let's say we have fed some text information. The model wouldn't be able to give the outputs, right? Because it's a real-time information. Because the percentages are rapidly changing, right? At any time, the percentage can change. So in that case, we can't do this by analyzing a text knowledge source. So there has to be functions linked. There has to be queries linked. There has to be different types of other sources linked. So in that case, let's see what kind of process are we doing here. So now you can see the model is returning this value called 9.95 of the orders are returned. This information comes from the e-commerce orders table in BigQuery. The query used to calculate the return rate was this, right? So you can see by analyzing the question, the model is calling the respective function that is required to get the percentage of orders. And at the end, you can see it gives me the percentage of orders by calling an SQL query from the database, right? So this is a very basic example. So this can be applied to anything, even for a reservation, even for a restaurant reservation, even for a food ordering platform, even for a hotel reservation platform, chatbots, right? So you can see there are a lot of use cases that we can use this thing for. So now, talking about function calling, first of all, we have described the functions. For an example, if you are building this restaurant, let's say food ordering chatbot, we have to say, these are the functions that I have defined. For an example, this is the function that I should call to add item to my order. And this is the function that I should clear the order. This is the function that I should call to place the order, right? In that case, we should say, these are the different functions I have, and these are the capabilities of these functions, and these are the inputs and outputs of these functions. First of all, I have described that. And then finally, we have the endless possibilities of integrating with external tools. So if you are building chatbots kind of applications, it's going to be a very interesting feature that you all can make API calls and you can link any third-party capabilities, right? So in that case, it gives you the capability to interact with external tools and get things done very easily. Right. So now, in Python, we can easily define functions, right? So there are different data types supported in Python. And here, what I do is basically, in function calling also, it supports several data types. For an example, you can see these are the data types that it supports. It supports integer, float, string, bool, list, and dictionary. So all of these data types are supported. For an example, if you want to input any kind of values to a particular function, you can use any of these data types to pass into that, and you can get the result out of the function. And also it has a JSON schema. So for an example, if you're using these functions in very advanced scales, for an example, if you're handling any kind of validations, any kind of input validations, or any kind of things like that, we can even use their JSON schema to define how the functions are working. So for an example, what are the inputs of these functions? What are the required parameters? And what are the arguments? What are the return types? So to define all of these things, you can use their JSON schema, or you can use their Python, the function handling operator. So first of all, let's work with a very basic example. So in this case, you can see it says define multiply. So we have a function called multiply, and these are the two inputs. So we have a float of A and float of B, right? And here we describe the output of this function. It says returns A into B. And you can see at the end, it returning the output of this result. And then I have to define the model. So I have to use Gemini Pro model to work with this function calling. Because in the Flex model, I think it's not supported. But I'm not sure about the 1.5 version. In 1.0 version, it wasn't supported. But in Pro version, along with Gemini 1.0 Pro, it supports. So now, along with the model declaration, I should pass the tools. So basically, I should define what are the functions. So here I'm passing the multiply function I have defined over here. And then let's see a basic example. So now you can see I have started chat session because I should be able to ask follow-up questions, right? So I had to ask back-to-back questions. So in that case, you can see it says, I have enabled automatic function calling as argument in the start chat operator. And finally, I'm asking the question. So I had okay, so now in a nutshell, if I describe that again, I had the function defined, I had the model defined over here, and then I had the chat session enabled. So along with the chat session, you can see it says enable automatic function calling, and I set that to yes. And then finally, I'm asking the question. So it says I have 57 cats, each owns 44 mittens. How many mittens is that in total? Right, I have 57 cats. Each of these cats owns 44 mittens. How many mittens is that in total? So now the model understands it's a multiplication, right? The model understands it's a multiplication. So what happens is the model would call the multiply function I have defined over here, right? So the model would call the multiply function I have defined over here because it says multiply returns A into B and it will give an output which makes sense, right? See how I can override the result, right? So in that case, if I want to give a specific output, I can give a specific output from here. And based on that, it will describe, it will come as the correct output. All right, so now let's see something in a practical manner. So let's see the coffee example, the restaurant ordering example I mentioned earlier. So now if I go back to my repository, you can find this example also. It says function calling. There's a Python file called function calling that you guys can see. I'm going to open it over here. Right. So now, again, you can see I'm using Gemini Pro model, the latest version. And here I have defined two arrays. The first one is called the orders array, and the second one is called the placed orders array. So here, this is going to be all the orders information, and this is going to be all the confirmed orders array. And now I have defined several functions, right? So you can see the first function is called add to order. And you can see there are certain, I'm taking the drink as a parameter and the modifiers. For an example, if I'm adding any kind of additional milk, additional sugar kind of thing, so you can add those modifiers over this as an array. And you can see, so whenever we define a function, we should have a comment like this. So you can see the comment says adds a specific drink to the customer's order, including any kind of modifiers, right? So what I do here is basically I'm just adding that into my orders list, right? I'm basically adding that into my orders list. And then I have another function called get order. So with the get order function, what happens is it will return the customer's order. So basically whatever the orders that has been placed in under the array, it will show these are the items that you have ordered. So it should revert back to the customer. And then I have remove item function also that removes an item from the orders array. And then I have the clear order function. And finally, I have the confirm order functions. You can see these are very basic Python functions I have defined. But for each of these function, I have given the comment and I have given the return type as well. So based on how it should return the output and how we should take the input as an argument. And finally, I have the place order function. So you can see these are all very basic Python functions, right? So now this is the most important thing. So now we should give the prompt here, right? So you can see I have defined the entire workflow as a text. So you can see it says you are a coffee order taking platform, and you are recently talk only about drinks on the menu, right? This way I give the constraints. Right, so you can see I have given all of these constraints, and then you can see whenever there's a customer's order, I should call the add to order function, right? So here I am mentioning which function to call, right? So I'm specifically saying these are the functions that I should call, and it says removing specific items with remove item, and reset the order with clear order. So you have to describe all of the functions that are available in your system. And you should also define what are the inputs of this function. And based on that, the system would respond, right? So you can see I have defined the entire workflow of this. So as given in this context, I have defined the constraints. And also I have defined the menu items and the work hours and the additions and the drinks, right? And modifiers and any kind of other stuff has been defined. And finally, in this line of code, you can say I'm registering all the functions to work with Gemini, right? So you can see it says I'm using these functions. I'm registering all of these functions to work with Gemini, right? Right. So now what I'm doing is you can see under this Gemini function declaration, I have passed these functions as tools. So I think I have already shown that at the presentation. So I'm registering all of these functions as tools. And then what I do is I'm using the model. So you can see either 1.5 Flash or 1.0 Pro I'm using. So basically what I do is basically if the function calling functionality is not there in 1.5 Flash, I'm instructing the model to use 1.0 Pro, right? That's a constraint I defined earlier. So you can see depending on the model availability, I'm using that. And then you can see I'm passing that information into my model as well. And also I'm defining some other stuff as well. I'm defining the prompt input, and also I'm defining the user and the model paths. And here I'm enabling function calling, right? So like I mentioned earlier, this works as a chat thread, basically where I can ask follow-up questions. So in that case, I should be able to ask follow-up questions. So I should enable the function calling as well, because I'm calling all of these third-party functions. So in that case, I'm enabling function calling over here. Right. So now let's see this in action. So I'm going to run this Python file. So let's see how it works. Right. So you can see it says, welcome to Barista Bot. So I'm asking question saying, can I place an order? So it says, yes, what would you like to order? So in that case, I'm asking, what do you have? Right. So now you can see right after this question, it gives me the menu. So I'm going to say, I want to order an espresso. So now you might understand that there are multiple ways these questions can be asked, right? So you can say, I want to order an espresso. Can I have espresso, right? So there can be multiple ways of asking this question. If it's like a fixed chatbot, the chatbot cannot process that information, right? So now that we are working with Gemini and the large language model, you can see it should understand any type of response. So now it says, I want to order an espresso. Now you can see the output has been given as, I have added espresso to your order. Would you like to order anything else? So I'm going to say, can I have Americano as well? Right. So now I'm going to say anything else right after. I'm going to say that's all. That's all. Can you repeat my order? Right. So you can see it says you have ordered an Americano and espresso. Is that correct? And say yes. Right. So I'm going to confirm this order now. Right. So now you can see it says I will go ahead and place your order. Right. So I'm going to say that's all. Please proceed. Right. So now you can see at the end of this function, you can see the output of the array of orders. So you can see I have these two functions. You can see I have two arrays, the orders array and the placed orders array. So here you can see the output of the placed orders array. So basically I'm printing the result of this array along with my confirm order function. So basically you can see the entire output of my order as per given in my array. right? So you can see how easy was that to build a function calling approach. So you can see in that way, the capabilities are endless. You can even call third-party APIs. You can even retrieve information from third-party sources, right? So things like this can be done with the function calling feature of Gemini. Right. Moving back to my presentation, I think I already mentioned about something called JSON schema as well. So now earlier we used the Python schema to define the instructions of handling the order. And now if I go back to my presentation, you can see that. Right. So before I move forward to JSON schema, let me show another example real quick. So in this case, you can see I have integrated a very basic Wikipedia search tool. You can see I have defined the function called Wikipedia search, and I'm inputting the list of queries. So at the end, it should give me the list of pages. So for an example, in this case, you can see I'm giving some additional knowledge capabilities where Wikipedia search can be done if I want to get a certain result, right? So in this case, you can see I'm using function calling here as well. And you can see that as a query, I'm giving this example as explain how deep sea life survives. So in this case, I'm sending that into my model. And you can see based on that, it's calling the Wikipedia API and Wikipedia search function. And you can see one by one, it's giving the output from Wikipedia. Right. So these kind of additional capabilities and additional functionalities can be introduced. And right, so these live examples are available. So once I share this slide deck, you all can go through the code bases and you all can see this stuff in real life. Right. So now let me talk about function calling schema. So I think I have already mentioned about the Python functions calling schema. Basically, this is the very basic approach on how to handle with the Python function calling. But if you are looking at very specific outputs, for an example, if you want to handle any kind of input validations, any kind of output structures, right, there has to be a very specific way of declaring that. So we have something called JSON Python schema, JSON schemas. So for an example, we can even do the Python function declaration by using the JSON parameter structure. So you can see for an example, in the early example, I have shown you on the multiply function. I have defined what is the function that I should call. And you can see it gives me the output of returns A to B. And then I'm defining what are the attributes. For an example, what are the keys and what are the attributes and what are the required attributes. So in that case, in case if you miss something, in case if you miss a particular parameter, it will say these parameters are required and you can't call this function without having these values, right? So in that case, you can define a JSON schema and the output will be much more accurate if you want to be very specific, right? So in that case, you can see I'm explicitly saying these are the number inputs and these are the text inputs. In that case, I can say these are the different data types and these are the output types. Likewise, I can easily say, I can easily instruct the model to work in the way that I want. Right. Okay. So we have some other questions as well. Okay. So we have a question for an educational site with a chatbot. We hope to fine-tune a LLM model based on the student textbooks to answer to a student question personalized to their grade, such that the grade 7 student will not be answered from the knowledge level of grade 10. Can you give me some guidelines on how to do that? Also, is it possible to have a singular chatbot? Yes. So basically, if you are planning to do that, I would say you have to go for RAG approach, retrieval augmentation. So I'll show you example of the retrieval augmentation of that as well. Because in this case, I would say you might have to work with a external vector database to label this information. For an example, if you are feeding the chatbot with grade 7 textbooks, in that case, there has to be contextual understanding, right? Because at the end, what happens is it will be different types of difficulty levels. So in that case, the contextual labeling has to be done. So in that case, I would recommend going for a third-party vector store and along with the labeling. So for that purpose, you can use something like Pinecone to work with that. And along with that, you can label the data. And I'll show you the RAG approach at the end of the slide deck, at the end of the presentation as well. Real quick. Right, so I think I have already mentioned about the JSON schema for function calling. And right, so you can even work with structured data. So for an example, if I want to retrieve the information in structured way, you can even retrieve the information as a JSON object as well. Because if you're building your own kind of application, maybe like your own chatbot kind of application, you might require the output to be in JSON format, right? Because you might be having a third-party backend service. So in that case, the third-party backend service would have to understand the JSON output that you're giving. So in that case, I would say the structured approach has to be there, because at the end of the day, you might want to get the output as a JSON. Right. Okay. So there are more examples here. So you can get these examples from the slide deck that I'll be sharing with you all. Right. Okay. So to wind things up real quick. So I think we are running out of time as well. I want to wind up with certain other capabilities as well. So when talking about large language models such as Gemini, it has the image understanding as well. So for an example, in this case, you can see giving image as an input, and based on the image, you can see it says write a character statistic sheet based on this character, and you can see this kind of output has been given. And now let's see how we can use this image capabilities in a much more helpful way for us. Now you can see it's a very basic handwritten form, and you can see it says in a way that it should support any kind of a form type, right? So what I can do is, first of all, I can instruct the model saying that this is how I should extract the information. So you can see I'm giving the JSON output type here, right? So you can see it says output is JSON, and I'm giving it an example. So you can see it says dog name is Fido, breed is Cavoodle, and color is black and tan, and age is 3. So basically what I do is basically I'm exactly giving the output that has been fed in written text, right? So which would understand the model, which would make the model understand these are the input data, and based on that I should provide the output for a second form as well. So you can see with these kind of capabilities, you can even do the information retrieval as well very easily, right? You can do the information retrieval. So without going for complex extraction model, you can see how this information retrieval can be done very easily with this kind of along with the Google AI Studio, because along with the function I have defined, the example I have given. So for the input type, you can see I have given the input type as form, and the output type has been given as JSON. And here I'm giving the JSON type, JSON output format that I wanted to get the information at. Right. So these examples are available. I would say since we have a time limitation, I don't want to take much time since you have passed 7 as well. I don't want to take much time into this. So I'll quickly go through the other examples we have in real quick. Right. So if I'm interested in fine-tuning models, for an example, these for the advanced intermediate people. So we have the fine-tuning capabilities so we can even fine-tune Gemini model as well. So if you are looking for specific purposes, so you can click on new fine-tune model from GenAI Studio, and you can provide your structured data from this, and you can give your you can upload that as a CSV file, or you can give your model inputs manually, and then at the end you can easily fine-tune your model. You can pick the model from here, and then by the structured data that you provide based on the inputs and outputs, you can easily fine-tune the model in a way that you want to get the response. So for an example, if I go to the documentation, you can see that I can provide this kind of inputs. For an example, the text input I wanted and the output that I wanted, right? So I can give the structure of information, and based on that, it will give you the output as based on the output format that I give, and you can feed as a CSV file, or you can even feed that as JSON file, and based on the structure that we define, it will fine tune the model, and you can reuse that model in your specific use cases. And it will be stored at the model garden, and you can easily do the information, any kind of structuring by using the fine-tuned approach. And finally, I want to add a small comment on the RAG approach. So if you are using, if you are intermediate level developer or advanced developer, you can, we have the RAG capabilities of Gemini model as well. So if you are using any kind of third-party embedding models or any kind of let's say if you're using any kind of third-party vector stores and all, it gives you the capability of using the RAG capabilities of Gemini. And also we have something called multi-model RAG, right? So like I said, Gemini is a multi-model which is capable of understanding image level context, video level context, and even text level context. So for an example, in this case, you can see you can even feed with images, text, and you can see there are multiple types of outputs given. So based on multiple types of inputs and outputs, you can even construct a very advanced level, very custom level model output. So these code labs are available. So you can, if you go to the Gemini cookbook examples under the Google's repository, you can find all of these examples. Those are available in very high level. So you can use these examples to build your RAG model as well. So even if you're using an external text embedding models, you're free to use that as well, right? So that's the beauty of Gemini, because you can work with multi-models, right? Even text data, image data, or any kind of audio data as well. You can use this model, right? It's a very advanced level of modeling. So going back to the previous question, so on the question, the chatbot to generate education information, I would say you can also go for the RAG, you can go for the RAG approach, and you can with Pinecone you can set contextual information, and you can give the labeling, and based on that you can, by using libraries such as LangChain, you can connect that with Pinecone, and you can cross connect all of these models such as Gemini multimodal, and you can get it done very easily. Right. So with that being said, that brings to the end of my presentation. Thank you very much. So let me see if there's any other questions that you all have gotten. Right. So we have one more question. If we want to fine tune for Sinhala, what is the easiest method? Fine tuning an English model and and then translating it to Sinhala, or another method, right? So it's like this. Fine. Okay. So I would say translation model is very common nowadays, right? People are, so even I have seen one of the biggest companies in Sri Lanka. I don't want to mention the name of it. And I saw that they have made a Sinhala chatbot, Sinhala GPT model. And in that case, what they're doing is they're getting the results all in English. And at the end, they are calling the Google Translate API and they're getting the result. But that's not the correct way of doing it. But if you are doing it for Sinhala, I would say there are a lot of data sets available on Hugging Face. You can use a Hugging Face to find the Sinhala data sets. So I would say you can even train that, you can even fine tune that on top of Gemini as well. But if you use GPT has now, GPT-4 has a Sinhala support as well. Gemini is being currently trained towards Sinhala as well. But if you use GPT-4, something like that, GPT-4 has Sinhala support as well. So you can maybe you can work with GPT, because GPT has been tuned with a lot of data. And if you use your fine-tuned data on top of that, you can improve the accuracy of GPT-4, and you can use it for your specific purposes. Because they are already using the fine-tuned data. In that case, just a matter of using a fine-tuned data set and applying it on top of GPT-based model. Right. Any other questions that we have? Right. So definitely I'll share the slide deck in a second. Right. I have shared the slide deck link in the chat section, so you all can go through it if you all want any other examples. Any other final questions? Yeah, definitely. So if we have any questions in the future about the education side, is it okay to reach out to you? Yeah, feel free to reach out to me on any social media platform. I'm available on LinkedIn, Instagram, or Facebook and WhatsApp. So if you can drop me a text on any of these platforms, I'm free to guide you all. Right. So if there's no other questions, we can wind up, I guess. Anything I missed? Any questions I missed? I don't think so. Right. So I guess we are all done for the evening. So I want to hand over to the organizers to carry it forward. And thank you guys for tuning in from 5 p.m. itself. Thank you very much. Really appreciate it.
So thank you so much, Mr. Suresh, for answering all those questions and for your enlightening presentation. Your expertise and willingness to share your knowledge with us have made this session truly special. So before we sign off, let's capture this memorable moment together. I invite everyone to turn on your cameras for a virtual group photo. If you're comfortable, strike a pose and let's create a snapshot of our fantastic workshop experience. Okay, so I'll give everyone a couple of seconds to get ready. Okay, is everyone ready? Smile. 1, 2, 3. Cheese. Okay, fantastic. Thank you all for participating in the virtual group photo. Okay, all right. So it's finally the moment that we've all been hinting at. Actually, we have 2 announcements today. The first one, we are thrilled to unveil the IntelliHack NextGen Delegate t-shirts, exclusively designed for participants just like you. These items are a perfect way to show your enthusiasm and commemorate your journey in this journey. But do hurry up because we only have a limited stock available. Details on how you can get your hands on these exclusive t-shirts will be shared in the chat box shortly. So don't miss out on this exciting opportunity. Okay. And next to the moment that we've all been eagerly waiting, the announcement of the finalists who made it to the final hackathon. This is the time to get excited and cheer for your peers. I'm thrilled to announce the teams that have made it to the final hackathon. All right, so we have code crafters and data mites from University of Colombo School of Computing, Team Innovation from University of Moratuwa, Kernel Newbies from University of Colombo School of Computing, Code Labs from University of Colombo, Morutu Pasanga from University of Moratuwa, Rapid Vortex from University of Colombo, Team Blazers from University of Jayawardenepura, Team Vertex from University of California. And last but not least, the Cipher Squad from University of Murtua. So congratulations to everyone who made it to the finals. We are excited to see what innovative solutions you will present in the finals. So before we conclude today's session, I would like to invite Savini Ratnayaka, the event secretary of IntelliHack, to deliver the vote of thanks. Savini, over to you. Savini, you're muted.
Sorry. Thank you, Bhagya. Good evening, everyone. As we come to the end of IntelliHack NextGen workshop series, I am filled with immense gratitude and pride. It has been an incredible journey, and none of this would have been possible without the support and contribution of many remarkable individuals and organizations. So, first and foremost, I would like to extend our deepest thanks to our esteemed speakers. First, Dr. Sumani Rajadure, your workshop on introducing to large language models was enlightening and set a strong foundation for our participants. And Mr. Sahan Disanayaka, your insights on developing LLM applications with Langchain and Hugging Face were invaluable. And Mr. Suresh Peiris, your workshop today on exploring the world of GenAI with Google AI Studio and Gemini was both fascinating and inspiring. And I would also like to extend a special thanks to our knowledge partners, Octave and GDG Sri Lanka, for sharing your expertise and resources. Your support has been vital and in expanding our knowledge and ensuring that our workshops were informative and valuable for all participants. And also, a heartfelt thank you to our gold sponsor, LSET, our ecosystem partner, AI-Driven Sri Lanka, our digital media partner, hackathons.lk, and our beverage partner, Pepsi. Thank you for collaborating with us and making this event a success. And also, I want to express my gratitude to all participants who joined our workshops. Your excitement to learn and willingness to participate have been truly inspiring. Last but not least, I want to thank my fellow organizing committee members. Your dedication, hard work, and unwavering support have been instrumental in making the IntelliHack NextGen a success. It's been an honor working with such a talented and committed team. So thank you all once again for being a part of this incredible journey. Let's continue to innovate, learn, and grow together. Thank you and have a great day.
Thank you, Savini. So with that, we come to the end of today's session. But before we wrap up, let me once again extend our deepest gratitude to Mr. Suresh Peiris, whose insights and wisdom have ignited a spark of inspiration in all of us. Your presence here today has added immense value to our workshop. And a big virtual round of applause to all the participants who joined us. Your enthusiasm, curiosity, and engagement have made this session an interactive and a dynamic experience. We hope you found this session enriching and inspiring. So thank you everyone for joining us today. Have a wonderful evening, and we will see you at the final hackathon of IntelliHack.